Okay, hello everyone. Let's get started here. So what we first want to do is let's see if we can refresh our memories on what we think the word acceleration means, what we think our acceleration involves, what we think are examples of acceleration. So we have here is a few different possible examples of acceleration, and we want to pick all of them that we think apply. So there are five choices for you. Pick as many that you think apply. So which of these examples do you think are examples of acceleration? Our example number one is Usain Bolt in the 100-meter dash. Example two is a bike coming to a stop at a red light. Example three is a skateboard bombing down a hill. Example four is a car on cruise control. And last example is the Earth rotating around the sun. So which of these, which of these choices are examples of acceleration? We currently have 13 people, so let us get 13 responses. We are at 7 out of 13 so far, which is pretty good, but we want to hit 100%. So we are currently at 9 out of 14, which is pretty good. Let's get 14 out of 14 people to respond here. So which of these are examples of acceleration? We are at 10 out of 15. We have five choices for you. Usain Bolt in the 100-meter dash, a bike coming to a stop at a red light, a skateboard bombing down a hill, a car cruising down on cruise control at 25 meters per second constantly, and last but not least, the Earth rotating around the sun. So pick as many of these as you feel like apply. Let's take a few more minutes for us to answer this poll. We are at 11 out of 16. We want a 16 out of 16. We want 100% participation. If you are one of the 7 who haven't responded, please do so. We are at 13 out of 18. Can we get a few more choices here? Let's get 5 more, 4 more. We just need 4 more. If you're one of the 4 who hasn't responded to the poll yet, please do so. If you can't see the poll, just message me what you think are examples of acceleration. We are at 15 out of 18. We only need 3 more. Well, we need 4 more now. We are at 15 out of 19. For those of you just joining us, I want you to pick which of the following do you think are examples of acceleration. I want you to pick all of them that apply, that you think apply. We are at 16 out of 20, which is 80%. Let's get 4 more. We'll take 1 more minute to go through this poll. 1 more minute for those of you to respond. So we just need 4 more to hit 100% participation here. Let's do so. We are at 17 out of 20. We just need 3 more. 17 out of 21. For those of you just joining us, I want you to pick all of these that you think are examples of acceleration. Okay, let's take 10 seconds. 19 out of 22. That's pretty good, but we want to hit 100%. Just need the last 3. Okay. We are at 20 out of 22. So for those of you who haven't voted yet, please do so. Okay, so which of these do we think are examples of acceleration? So we talked actually quite a bit about this first example, Usain Bolt in the 100-meter dash. Most people have agreed that Usain Bolt in the 100-meter dash is an example of acceleration. We actually talked about this quite a bit on Monday. So Usain Bolt, so A is an example. It is an example of acceleration. Because when you start off in a race, right, you are stationary and then you have to accelerate up to your top speed. And so Usain Bolt in the 100-meter dash is an example of acceleration. This is something we talked about quite a bit on Monday. What about a bike coming to a stop on a red light? We got about half the people seem to agree that this one is an example of acceleration. So this one is kind of weird. It's a bike coming to a stop. So usually when we think about acceleration, we usually think about acceleration as going faster. However, acceleration can also mean going slower. Usually we use the word deceleration for this, but technically an object slowing down is an example of acceleration, because if you remember, acceleration is a change in our velocity, any change in our velocity, and one of the components of velocity is speed. So if our speed is changing, if it is going up or going down, that is indeed an example of acceleration. So B is also an example of acceleration. This is just slowing down instead of speeding up. C, about 2/3 of people agree that C is indeed an example as well. I also agree. A skateboard bombing down a hill is an example of acceleration because the skateboard is getting faster and faster and faster as it goes down a hill. What about D, a car on cruise control? This one is not an example of acceleration because a car on cruise control is not accelerating. It's not going faster. It's not slowing down. There's no change in its speed. There's no change in its velocity. Therefore, the car on cruise control is not accelerating. Last but not least, the Earth rotating around the sun. This is an example of acceleration. This is indeed an example of acceleration because the Earth rotating around the sun is always changing its direction. Now, if you remember, acceleration is a change in our velocity. Our velocity has two components. It has speed and it has a direction. If either of those, or if both of those are changing, it means that we are accelerating. So the Earth rotating around the sun, the speed is not changing, right? It's not going to be speeding up or slowing down. However, its direction is going to be constantly changing because one direction is going this way, and another direction is going this way, and then another second is going this way. So its direction is going to be constantly changing. The counterclockwise and clockwise is not a direction for velocity. We got to consider just basically, is it going this way? 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 And so therefore, the Earth rotating around the sun is indeed an example of acceleration. So to sum up, A, B, C, and E are all examples of acceleration. D is the only one that is not an example of acceleration. So thank you for all of those who are responding. Today, what we're going to be doing is we are going to be doing a little experiment to sort of test how we think different variables affect our ability to accelerate. If this is on Canvas, I will post a link to it right now. Before we get started, I do want you to, we're going to write down some definitions first, but you can start opening this up. So that's the main assignment we're going to be working on. In terms of that assignment, there's a few sections on it. I want us to finish the variables and procedure section today. It's a mandatory, super important. That's the only due date. We have plenty of time to do it in class. So my expectation is that everybody finishes it today, by the end of today. Very mandatory, very important. This is not flexible. I will not budge on this. Okay, so that's what we're gonna do today. Before we get started with that, what I first want you to do is I first want you to pull up your graphic organizer that we were working on Monday. And I want you to try to write down a definition, an example for velocity. I want you to try to write down a definition and an example for acceleration. I want you to try to describe a relationship between acceleration and velocity. And then I want you to try to write down what you think are the difference between acceleration and velocity. So this should be boxes O, P, Q, and R, I think, on the graphic organizer from Tuesday, apologize, Tuesday. O, P, Q, and R. So take a few minutes to write down a definition and example for these four particular things. I think it's important to be able to distinguish between them, have an understanding of all of them. So I want you to write down a definition, an example in your own words for these four different things. We'll take about 6 or 7 minutes to do this, and then we will move on after this. So if you're unsure what we're doing, I want you to open up your graphic organizer from Monday. I want you to write down a definition and an example for velocity in your own words. I want you to write down a definition and an example of acceleration in your own words. I want you to write down what you think is the relationship between acceleration and velocity. And then I want you to write down a difference between acceleration and velocity. Let's take another 2 or 3 minutes to write down definitions for these, and then what you think the definitions for these are, the relations between these, and then we will move on to the experiment we will be doing.
You seem tired. When you got an extra hour of sleep, how do you feel?
Another minute or two, and then we will move on. Okay, so what we are going to do is we are going to design an experiment that allows us to test how height and stride length affect our acceleration and velocity. So we talked a lot on Tuesday about how different physical traits of Usain Bolt allowed him to either benefit his racing or be detractors from his racing. However, we actually want to test how those things actually might affect one's ability to race, right? It's not in science, it's not enough to just think or just create ideas or theories for what something, how things might affect things. We actually need to create experiments and actually test out these different ideas. So our goal today is to create hypotheses for how height and stride length affect our acceleration and velocity. And we want to design a procedure to test these hypotheses. Then we are going to determine what variables we want to collect data on. So one thing that I want you to do is we are not going to finish the whole thing today. What I want you to do is I want you to finish everything up to the procedures and the variables section, which is clearly marked out in lots of big, bold text. Make sure you finish that today and you submit your Google Doc on Canvas today. We will continue working on this next week, so I don't expect you to finish the whole thing because we won't finish the whole thing. We definitely won't. But the reason why I need you to submit it today is because I need to figure out what data our class needs to collect as a whole next week. If you do not submit it today, I won't be able to get the data you need, and then you're going to have to figure out how to get the data yourself. So I am not going to help you at all if you don't submit it today. So you have plenty of time to do so. We have 53 minutes to just fill out a few things. So I expect everyone to be able to finish the procedure and the variables today. So on the assignment itself, I'm just going to quickly go over it. What your first thing to do is I just want you to quickly write down a definition for acceleration and velocity again, just in your own words, just as a way of it just so you have a quick reference on it for your own ability to review. Then what I want you to do is I want you to create hypotheses. I want you to create hypotheses. I want you to think about how you think stride length affects the velocity of a runner, and I want you to write down what you think how height affects the acceleration of a runner. So I want you to just quickly jot down how you think those affect the acceleration or the velocity of a runner. Then what I want you to do is I want you to just design a procedure to test your hypotheses. What do I mean by this? I want you to just decide how are you going to test your hypotheses? What are you going to try to prove? What kind of data are you trying to collect? What kind of evidence are you trying to collect? What kind of procedure is your experiment going to involve? So I want you to figure out some way to test or prove or disprove your hypotheses, right? So if you're claiming something, you need to be able to somehow prove it with some data, some experiments, whatever. Your procedure. So the way this is going to work is that after you submit your procedure, I am going to look at everyone's procedures and then I'm going to have sort of put together a way for everyone to conduct your procedures. So when you are writing your procedure, you should write your procedure in a way that is doable for any random person in this class or any random person in the world. So in terms of your materials, in terms of the difficulty of the procedure, in terms of the physical activity it requires, right? Keep it realistic so that anyone can do it without too much difficulty. So that's what you should consider in terms of your procedure and in terms of data, what data you should be collecting. So in terms of what data should you be collecting, you're going to write down what variables you want to be testing. So what do I mean by what variables do I want to be collecting? So for example, if I wanted to test a hypothesis that bigger dogs eat more than smaller dogs, what I might want to do is I might want to collect the masses of the dogs, and I might want to collect the data on how many calories they might consume in a day. So for example, an example variable for that might be dog mass. We are not testing this hypothesis. We are testing one involving, height and stride length. So you may want to, you should think about what variables you want to collect, what data you want to be collecting. So yeah, and this should include any data you are trying to collect or you want to measure in your experiment, not just, the basic ones. That's all you need to finish by then today. And by end of today, that's all you need to finish. If you finish this early, you can start with constructing a data table below. But I have instructions for that. If you have questions on that, you can let me know when you get there. But I do not expect you, or I do not need you to be that far. I just need you to fill out your hypothesis, your procedure, and some variables to test. So if you don't have any other questions, I'm going to send you to your groups to let you get started. You may work on this as a group if you feel like you would rather do this in a group. I know one group, I have one breakout room where people want to work individually, which is also okay as well. So I'll leave it up to you whether or not you want to conduct this, do things as a group, or if you want to do these individually. Otherwise, I will let you get started and put you in your groups, and then, yeah, we'll see how things go.